it's time for us to start looking at coupled objects, which means more than one object that are having influences on one another. So we'll start out with, say we have three different blocks. Okay, and so we'll label them block 1, block 2, and block 3. Okay, and let's say we have some force F that we're applying to block 1, pushing it to the right. Okay, so the first way I'm going to solve this problem is in the same way that your book solves it. And the reason I'm going to do it that way is because this is really a very powerful framework. If you solve every problem that you have using this method, then as long as you account for all the forces properly, you're always going to have the right answer. And so in this video, I'm going to show you how you would solve just a simple problem like this using your 6 ideas method, which you can apply to much more difficult problems. But then I'm also going to show you in the next video how to solve this problem in a much faster way, and so that can act as a good check for you for some of the simpler problems. But I found that if you try and solve all of the problems that you have in the way that I'm going to solve it in the next video, I think you might find that you're going to be making a lot of mistakes and leaving things out. So I think it's really important to go through the full framework from your book to work out this problem, so you can see how we would apply this to objects in general. So the first thing we'll do is we'll look at mass 1, and we'll look at all the forces on it. So, well, actually, I guess first what we should do is we should draw our free body diagrams. But we'll draw all the blocks separately, but next to each other. Okay? So on block 1, we have a gravitational force going down. We have a normal force pushing up from the ground. And we have a force F pushing from the left. But then from the right, we also have a force F21, which is the force from block 2 on block 1. Then, if we look at block 2, we see that we also have a gravitational force pushing down on it. We have a normal force pushing up, and I'll distinguish. We have M1 and M2 because these aren't necessarily the same mass. And then here we have a force 1, 2. Right? We have a force from block 1 on block 2. And then we have our third block, 3. Once again, we have gravity pushing down. We have a normal force pushing up. And now, once again, we have a force from block 2 on block 3. And so then this also, looking at this, we say, oh, well, I left out a force, didn't I? I left out on block 2, we should have a force 3, 2, because block 3 is also pushing on block 2. Okay? And the way that I know this and the way to check is because we should always have, connecting all the blocks, we should have these partners, right? And they're equal and opposite in each direction, just like Newton's law tells us they should be. But if I just look at one block, right, I only get like half the equation. If I'm looking at, when I look at block 1, I'm only getting part of those partners. When I look at block 2, I'm getting another part, and when I look at block 3, I'm getting another. Okay? So now we can go down and we can look at our block 1. So we look at the net force. So mass 1 times the acceleration is F in the x direction, 0 in the y direction, minus, we have, plus, I guess, a minus F21 in the x direction. And then we have a normal force 1, and, oops, sorry, that's in the y direction. And of course we have gravity, right? And we know our acceleration, we're not moving these up and down. So again, this is going to be a in the x direction and 0 in the y direction. Okay, now if I look at mass 2, we see basically the same thing. We say m2a. And notice that this is the same acceleration, right? These blocks are both going to be, like, these blocks are together. So the acceleration of 1 is going to be the same as the acceleration of 2. And so we notice this is f, oh, sorry. Yeah, this is f 1, 2, pushing in the x direction, minus f 3, 2 in the x direction. This is going to be normal force in the y direction, and minus a gravitational force in the y direction. This is also a0. And then finally m3. We'll have m3a, and again, same acceleration. We have an f23 in the x direction. We have a normal force in the y direction, and we have a minus a gravitational force. Okay, so now that we have all of these, now we can actually start to solve for this. All right, and so I'm sorry, we should also have an m3a here. This should be m2a. And this is m1a. Okay. So now we can look at this last equation and we can actually solve this. And so we say that that the acceleration a is equal to f23 over m3. Or similarly, we can say that f23 is equal to m3a. Okay, so now we have f23. But we know that this is also equal to f32 in magnitude. So now we can go back to our second equation, and we can say, well, this means that a is 1 over m2 f12 minus f23, which is equal to 1 over m2 f12 minus m3a, or in other words, f12 is equal to m2 plus m3 times a. And of course, this is equal to f21. So now I can go back again and look at the first equation and say that a is equal to 1 over m1. And then here again I have f minus f12, which is 1 over m1, f minus a times m2 plus m3. Let's see. So now, moving terms to the other side, I see that that a outside of m1 plus m2 plus m3 is equal to f, or in other words, I see that we can rewrite the acceleration as a equals f divided by m1 plus m2 plus m3. We see that this has units of acceleration, So our units check out because we have a force divided by a mass, which gives us an acceleration. And we see that it makes sense, right? If we look at each step along the way, so we see that the total acceleration is the force that we're applying divided by the sum of the masses. And so that makes sense. We see that, at each step, so the force that we're applying is equal to the acceleration times all of the sum of all the masses, which is all of the masses to the right of the force. The force of 1 on 2 is the second two masses, right? Here's F1, 2, and so it's mass 2, mass 3 times the acceleration. And then F2, 3 is just equal to m3 times the acceleration. So our answer makes sense. And so this is actually a very long way to go about solving this problem. But when you have more complicated problems and more complicated objects, using this method is going to make sure that you always get the right answer. But in the next video, I'm going to show you, a simple 2-minute way to solve the same exact problem.